Good evening. We're going to come back to a familiar topic, extend it a little bit today, and tonight we'll lay the foundation for that, and then going forward we'll get back to some properties of exponents and applications of those. Only now we'll be getting into, and we'll see the introduction to it a little bit today, the exponents can be fractions in addition to integers. So we're looking at nth roots, okay, the second root, the third root, the fourth root. That's what we mean by nth root. We don't know what number it'll be. Typically we're working up to 5 or 6, typically no higher than that. So if we look on the left side here, if b to the n equals a, okay, so something raised to the n power is equal to a, then b is an nth root of a. How do we write that? What does that mean? Here's how that goes. All right. So what are we looking at? B is an nth root of A. So we're taking the nth root of A is equal to B. Okay. So it's the nth root. We've seen cube root. We've seen the square root. Maybe even the fourth root. But whatever the nth root happens to be there, that's what those are there, the nth root, taking that there. So if we look at the right there, a little bit of a description of what's going to happen and how many roots we're going to have. For n being any integer greater than 1, and a being any real number, if n is odd, a will have one real root. That comes from the fact that we can have positive and negative odd roots, as opposed to evens where we can only have positive. So if we look at when n is even and a is positive, a is going to have two real roots. That's something that should seem somewhat familiar, because if we take the square root of something such as 4, okay, that's a second root, so it's an even root. 4 is going to, square root of 4 is going to be plus or minus 2. So we have two real roots for those. The same way, when n is even, again, if we took the square root, since it's the one we're most familiar with right now, and a is 0, we're taking the square root of 0, well, that's just equal to 0. So that's the only one real root when n is even and a is equal to 0. And the last one is when n is even and a is negative, a has 0 real roots. So if we were to take the square root of negative 4, again, we know that we can use the complex number system and get a square root there, but there will be no real roots here for this particular example as we go through those. So make sure you have that stuff down. It'll mean a little bit more to you as we go through with these examples and refer back to some of those concepts. A couple of brief examples here. It tells us to find the indicated real nth roots of A. So in the first one, we're asked to find the third root of negative 125. So what that means is we would write that as follows. The cube root of negative 125. Just to serve as an introduction to some other things, we can also write this as negative 125 raised to the 1/3 power. Regardless, we are asking ourselves what number multiplied by itself 3 times gives us negative 125. Well, 5 times 5 is 25, times 5 is 125. So the cube root of negative 125 is actually going to be negative 5. We have a negative root, but we have an odd index there, so that will give us one real solution, and that happens to be negative 5. For the next one, we're asked to find the fourth root of 16. Again, this could be written as 16 to the 1/4. We're asking ourselves what number multiplied by itself 4 times gives us 16. Well, that's going to give us plus or minus 2 as our answer. Because 2 times 2 times 2 times 2 is 16, and then the same thing with negative 2, since there are an even number of them there. So just a basic example of how things will be written. We have an index of 4 and an index of 3 on these two examples, and we'll go from there. So let's come back to that 1 over whatever as the exponent. So let's say that a to the 1 over n be an nth root of a, and let m be a positive integer. Okay? So if we take a look here, we have something like a to the m slash n. This is equal to, and this is how we'll simplify a lot of these. This will be a to the 1 over n. We'll take the nth root of a, and then we'll raise it to the m power. So what we're doing there is we're essentially to a power property of exponents and factoring out the m. Sometimes these could be rewritten also as the nth root of a all to the m power. So it's really important to understand, especially the beginning part here, because that's what we'll use the most here in this class with a lot of our examples. Talk about 3 examples. These are the only 3 I'm going to give you tonight. Obviously, eventually we're going to have variables involved, but this will give us a good place to start. One thing to really know, and that's why this first example is here, anything to the 1/2 power is the same as taking the square root of that number. So the square root of 64 is plus or minus 8. That's how we do that. Okay. Similarly, when we take 9 to the 3/2 power, we rewrite this as 9 to the 1/2 all cubed. 9 to the 1/2 power is 3. So this is 3 cubed, which ultimately gives us 27. 27. And I'm not going to be a stickler for the pluses and minuses because it would be very cumbersome. So this is all you really need to show at this point in time. In our last example, again, we go through the same process. A couple of different ways to go about it. This is one of them. I'm going to have 32 to the 1/5 power, all raised to the negative 2. The 5th root of 32 happens to be 2, so I get 2 to the negative 2 power. Again, negative exponents we have to move. This becomes 1 over 2 squared, which ultimately gives me 1/4. This is a basic introduction to the process of separating the fraction exponents so we can calculate roots. Ultimately, we will be solving equations with these in a couple sections, but we're just laying the groundwork for that. That's all I have for you tonight. We'll obviously practice this process and some of the properties of exponents over the next few days. Hope you have a great evening, and we'll see you tomorrow.